welcome to another edition of the Code Coder. Remember, I want to make you great and help you innovate. So last time I talked to you, we were actually using Xcode to create iPhone apps, and now we're going to continue on, and we're going to stay in Playgrounds because I want to start. I want to teach you some of the basic structures of the Swift programming language. All right, so to do that, I'm going to start. On my desktop, we have the Playgrounds that we did the other day, yesterday, and I'm going to go ahead and open that up. There it is. Okay, and we can go right to it. It'll run. It's right now. It's launching the simulator still, and so you see that the things we did yesterday are going to end up showing up here. That's when it's ready, and we'll give it a couple seconds to start, and then we'll get after it. There it is. So, all right. So I'm going to try to get rid of all these pieces here, keep the imports there, and let's talk about a little bit more. First, let's talk about Boolean expressions. Okay, Boolean expressions basically are more than what you see in your math class. Your math class, you have equals, less than. Well, in computer science, you have the same thing, but there's more to it. In order to show something's equal, like we showed yesterday, if you had var x equals 3, we showed you that 3 actually goes into the x and x becomes 3. But what if we wanted to check to see if x was 3? We would actually add an equal sign, and now we're comparing, does x equal 3? Okay, so it's not like in the way I wrote this, so let me try to do this in a different way. Maybe I just forgot that. All right, yeah, I did. Oh, no. What's it want? Okay, so it wants to insert that. No, we don't want to do that. No. So let's start with something like this. 3 plus 2 equals 5. Okay, so that's a question. That's a Boolean operator. Okay, so it's basically saying, does the left side equal the right side? And 3 plus 2 does equal 5. Okay, it's not 3 plus 2 equals 5. It's does 3 plus 2 equal 5? Okay, are they equal on both sides? Same thing for, like, if I did, 4 plus 5 equals 8. What would happen? Well, that's false, because on the left side it equates to 9, and on the right side it equates to 8. So these are Boolean expressions, and sometimes you have to write these, especially when we go into if statements and loops. So let's do some more. What if I wanted to see if something was not? You can actually use the exclamation point to see if something's not. So we could go something like, let's say, 3 not equal to 5. Is 3 not equal to 5? True, it's not equal to 5. How about is 4 plus 5 not equals, oops, can't do that. You gotta go not equals 8. Okay, see what happens? That is true, because 4 plus 5 is 9, and so it does not equal 8. So that's a true expression. And then the last one, I'll show you, it just gives you an error. 3 plus 5 equals 8. Now what's going on? You see how you can't, with the single equal sign, you're trying to assign 8 to this side, and there's no variable to catch the 8. It's just saying 3 plus 5. This is why your math professors freak out at computer science. This expression right here, okay? So 3 plus 5 doesn't equals 8, but it does equal 8. Okay, so then it becomes true. Okay, very nice. All right, let's erase that. Let's look at some other stuff. So you have other stuff like, 9 is greater than 7, okay, and that's going to be true. You could do 9 is less than 11. Okay, remember we got the same space on each side. True. Okay, let's go, like, how about 3 plus, I don't know, 4 is greater or equal to 7. Okay, so you have to put these together, equal to 7. Okay, I think that's right. All right, nice. Okay, so that's true. It's either greater than or equal to. Okay, Let's try another one. How about 3 plus 4 is less than 7? 7. Okay, is it greater than 7? No, it's not, so it's going to come out false. Okay, again, these are logical Boolean expressions, and it's just how this computer language, all computer languages work like this. By the way, if you learn this here, it's the same for all computer languages. So you just have to learn how a computer does these expressions. You know them in math. Now here's how they're done in computer science. Let's try a couple more. Let's go 5 plus 6 is greater or equal to 11. Okay, that seems about right, so that's going to come out true. Okay, but what about if I go 5 plus 6 is greater than 11? What happens there? False, because it's not, actually it's 5 plus 6 is less than 11. No, it's not, so it's false. Okay, now what could happen is we could compound these on both sides, really make a big expression. Okay, so these are compound Boolean expressions, and they have logical operators with an and, an or a not. Okay, so let's see how these work. All right, so let me erase all this, and I'm going to have, let's say I get a variable age, let's say equals 12. All right, so there's age is equals 12, and then I could go age is less than 10, and age is less than 15. So age is less than 10 and 15. Can that happen? No, it's false. Okay, because age is 12. So it's not less than 10, and it is less than 15, but it's not less than 10. And with this and, this is very strict. When you see the and, the ampersand, it means both sides have to be true. You got to have, let's see if I can do this. You have to have a true on this side, and you have to have a true on that side to make this a true statement. So if one side is false, the whole thing's false. Okay, so let me get rid of that one. All right, let's try some other ones. Okay, I'll get rid of all that. All right, so let's go this time. Actually, let's comment stuff out. Show you how we comment stuff out. That's how we do it. And let's go var age equals 18. Okay, this time. And then let's go age is less than 10. Okay, or greater than 10. And age is less than 15. So are both sides true? No, once again it's 18, so it's not less than 15. All right, so this comes up false. All right, so I feel like that the other one should have been true. Age is great. Oh, that's right. The other one was age is, well, let's comment this one out and go back to 12 and see what comes out of it. So we do that, and all of a sudden, no, it's true. Okay, so see how I used comment code to quickly go through and test my code out. If it's 12, it's true. If it's 18, it's false. All right. Let's do a couple more. Let's do something with some strings. Okay. So let's go. Let name equal, let's say Jackie. Okay. And let's have name equals Jack. So basically, does name equal Jack? Okay, this is comparing. No, it doesn't, so it's false. Okay, let's try a couple. Let's do an or compound Boolean expression. Okay, so let's go name equals Jack, or stovepipe name equals Jackie. Okay, and let's put the quote here. Okay, and let's see what that comes to. And I think we're messing with it a little bit. Let's move it over, see what I did wrong. name equals Jack. Oh, I forgot the quote here. So I like doing these live so you can see I'm making the same mistakes as you're probably going to make. Okay, and it still has problems. Oh, equals. Okay, so Jack equals and name equals Jackie. Okay, and it looks like now it's having problems because I don't have the same space on each side. So it's hard to do these live and get it right. And I'm glad I'm not, because again, you're gonna have problems. I want you to see that I have problems, so no one's different here. All right, so there it is. So if it's an or sign, stovepipe, then the restrictions are less. All I have to do is make one side true. Okay, so in this situation, this is false, and this is true. So yeah, when you have the stovepipe or the or statement, you only have to suffice one side. Okay, pretty cool. What about a not statement? Let's do a not statement. All right, with a compound not statement. Okay, that sounds crazy. All right, let's go. Let is a girl equal to true. Okay, these are common ways to code. Is a girl is you know, it's like it's a common Boolean variable name. Is a, you know, is a sum. Anyway, so let is a girl equal true. Okay, and now let's go with a not. Is a girl and name equals Jack. I think I'm supposed to leave the Jack from the last one. Sorry, I forgot to do that. Let's actually leave that in there. Let name equals Jackie. Okay, sorry. All right, so now I have is a girl. So now they both have, this is a not. This is hard. Okay, so you got to stay with me here. All right, so this is not a girl. So this has to be false. Okay, it's an ampersand. So they both have to be true. So it's already a false statement. Okay, I don't know what this is. All right, it's trying to save something. All right, and so this side has to be true. They both have to be true. When one's false, it already makes the whole statement false. Okay, and as you see up here, it is false. Okay, so that's one way of doing something. That gets confusing, huh? All right, let's go to another one. Let's go is a girl and a compound statement on this side. Name equals Jackie. Okay, so it has to, remember, for a Boolean, an ampersand or a and expression, I have to have true on one side. Oops, I just put a tab there instead of T. Sorry, I'm making this up as I go. And then on this side there has to be a T. Okay, true, and there is, because is a girl is true and Jackie is true also. Okay, so those are not statements. Really big. You want to do a really huge one? All right. Sorry, I got an itch on my lip there. All right. Here's kind of a big one. Okay, watch how complicated these can get. Okay, you thought your math classes were complicated. Watch this statement. Okay, so I'm gonna go not is a girl. I like how that comment code or completion code comes up. You just hit return. This is going to go off the screen. Name equals Jack. Okay, so close that brace. It's already trying to terminate it for me. Okay, there it is. Oops, forgot the quote. There you go. All right, but then what if you put a or in between here? All right, so one side, so that's already false, because you know is a girl's true and it's saying not true. So that's already false. But if I did a stovepipe here, an or statement, only one side has to be true. So if I do this logical expression true, then this is going to be a true expression. So let's take a look at it. So I'm going to go, on this one, I'm going to go is a girl. Love that code completion. Love it. All right, and name equals Jackie. So that's true, right? So if that's true, then the whole thing will be true because only one side had to be true. See that? That's a big statement. A compound Boolean statement. Okay? So you got tons and tons of stuff there. And yeah, so I'm going to stop there with the Boolean conditional statements. And I'm now going to talk about if statements. Okay? So conditional statements are something you've been doing all your life. I know your mom and dad have always told you, if you do your homework and you clean the kitchen, you could go out tonight. Okay, so you've been doing conditional statements all the time, or conditional situations throughout your entire life. If you clean your room and you do your homework, you could watch the World Series. You know, so you knew the conditions. Okay, sometimes it would be if you clean your room or you clean the kitchen, you can go out. Right? So you've been doing these for a while. You know the circumstances of them, and now we're going to do them in computer science. Okay, the computer science style. All right. So let me get rid of this. All right, and I'm gonna go. Let's do a let. Let's talk about roller coasters for a second. Okay, so you know when you go to Disneyland and they have a sign that says too short, or you have to be this height to ride this side, we're going to do something like that. There's going to be conditional statements on whether you can get on a roller coaster ride. Okay, so we're going to say let height to ride alone equals, let's say, 48 inches. Okay, let's make it a double too. Okay, so let's do something like that. So that's a double. Okay, let's make our height. Our particular height, let's say, is 49.5. Okay, by the way, did I? Yeah, okay. So these are really small kids, but they're kids. All right, so you got that. And now let's do an if statement if we get on this roller coaster. So if height is greater than or equal to height to ride alone, okay, and now we're going to do a curly bracket, or we're going to open a little curly bracket here with a curly bracket, the closing one, and then you have a little, this turns into a little function. We're going to print something to the screen. Print you are tall enough to ride this coaster. Okay, something like that. Okay. Whoops, print, sorry. Print. Okay. Something like that. Okay. So if you look at that, you come out, ooh, did I just crash? Holy cow, I just first crashed during a during a podcast. Oh my gosh. Yeah, so I crashed. Look at it, said that you crashed. Do you want to reopen? Yeah, I always get nervous about reopening that, thinking they're not going to reopen the right one. Oh, but I saved all my stuff. How cool is that? All right, so everything's saved. So I basically did this Boolean expression. If height is greater or equal to height to ride alone, print you get to ride the roller coaster. Now this is starting, and so now if I look at this, there you go. You are tall enough to ride the coaster. Okay, so that's a conditional statement. All right, so what if you weren't? You know, this just happens to be if you were, you could ride. But what if I wanted to? Okay, well, print. Yeah, you can ride, but if you can't, print. Sorry, try again or something. I don't know. Let's try to do an else statement. Okay, so with an else statement, I'm going to go right after the last one. Let's turn this off so it gets kind of compressed here. And let's go else, and let's go, something like that, and open another one. And let's go print. Sorry, you cannot ride the coaster. Okay, there you go. So that's an else, that's an if else. So there you go, and you can see it's going to say you rode the coaster, but if I change this thing to lower than 48, let's say if I go to 47, you're going to now see that you cannot. Sorry, you cannot ride the roller coaster. There it is. See that? Sorry, you cannot ride the coaster. Okay, so pretty cool. All right, so that's an else if statement, and that's an if statement and an else if statement. Okay, so what if I wanted to go if you do the dishes, okay, else if you clean the kitchen, else you don't get anything, you know. So it's a if, else if, else statement. Okay, let's see what that's kind of big. Let's just try to do it. It'll probably make more sense if I just write it out for you. Okay, so watch this. So actually, let's undo that. That actually is right. I'm going to go right here. I'm going to go else if. Okay, and I'm messing up this example. So let me try to add something to this example. So I'm going to say, okay, if you're not tall enough, if you ride with an adult, you're okay. So if you're this height, you can ride. If not, you can't unless you have an adult. All right, so let's make another variable. Let height to ride with adult, okay, equals 36. Okay, so if you're over 36, you could go with adult. Okay, so let's see what this does. So we're going to go else if height. I could actually put in another if statement here, and I'm going to go height is greater or equal to height to ride alone. Okay, that looks good. No, hide with adult. There it is. I love how that code completion comes up. Okay. All right, and then after this one, I could now do my else, and this one actually is. I'm going to say you can write. I'm going to actually take this one out of here. I'm going to copy this one, and I'm going to go ahead and put a here. I'm going to print this. Sorry about that. I'm getting caught up here real fast for you. Paste. Okay, so sorry this one, and this one says, instead of this one said sorry, it's going to say you can ride with an adult. Okay, so there you got an else, an else if, and an else. Okay, so since he's 47, so he can't ride alone, but it goes to else if. It says if you have a certain height, you can actually ride with your adult. So it actually does. If height is greater or equal to height to ride with an adult, which is 36, he's above 36, so it goes in here. Okay, now let's see if I could bump it down. Let's say he's only 35, he or she. All right, and there it is. Sorry, no. Okay, so isn't this great? This Playgrounds is great to play with. I want you to enjoy it, kind of get in there, move things around, see if you guys can make sense of it, and redo all my examples and make them work for you. Okay, let's see. That seems like just about it for today. So again, what you did today was you did Boolean expressions. Okay, you have all the equals, less than equals, equals, not. You're gonna also do compound Boolean expressions, and then you got to do conditional statements also. Okay, so again, don't forget to subscribe, and we're trying to make you great and help you innovate. Thanks a lot. We'll see you in the next one.